So let's move on. So let's go back and actually let's go forward to the phaser physics. I'm going to go ahead and switch the title of the stream so that we are up to date here. We're going to switch to the Space Invaders homage. Let me change the, you're going to get like bazillion screens on there for a second. Let me change the stream title to be Bug Invaders is what we're going to call this. Bug Invaders Game Dev. Okay, let's save that and see it update there. Okay. So now that that's set, let us move on. So, we've handled basically how to select, highlight, change options, and now we're jumping into physics. So let's jump in and make a sprite. Oh wait, we gotta go back. We gotta see, at the beginning here, they show us a completed version of the game that we're gonna build. Whoa! 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 So this isn't exactly Bug Invaders yet. This is more like, there's another arcade game like this where you're just literally avoiding things. You're not shooting. Isn't it like Centipede or something that was like this? See how far we can get. Oh, okay. See if we can do any better. Nope. All right. So building a phaser game with physics. I wonder if my character will make that jump. Every gamer ever. I probably have said that at some point to myself. All right, figuring out the rules of a video game is one of the joys of starting a new game. We wonder how fast our character can go, or how high it jumps, or what happens when it touches the enemy sprite. As a developer, implementing these rules is about deciding the physics of our game. The physics of a game determines how game objects interact with the game world. In this lesson, we will be using one of Phaser's built-in physics plugin to create a game with set rules and interactions. We will begin constructing the game we see in the browser. Go ahead and test it out. Control the player sprite using left and right arrow keys to avoid falling bugs. Yes, indeed. So we will be building this in the next hour or so. And as you can see, they're using the little Cody character like they normally do. Purple Teletubby. Oh, okay. Alright, so let's jump in and make a sprite. We've made sprites before using the this add sprite, but this time we're going to use this physics.add sprite and have our sprite affected by physics. In this case, our sprite will feel the effects of gravity. The method this physics add sprite takes 3 arguments: the x-coordinate, y-coordinate, and the image in the preload. So it's the same as the regular sprite, except we're going to do physics, add physics to it. Okay, so in create, call this add physics, or this physics add sprite with the Cody image. Okay, so this, as you can see, they've added in their bug sprite there, but it's not affected by any physics. It's not affected by gravity because it's only initiated with this add sprite. That's good for like background images and things that don't move. But for any moving things, we want to add the physics in. So this .physics.add.sprite, x-coordinate of, just make it positive, make it somewhere. We'll go ahead and try to put them on like underneath, like the bottom of the screen somewhere. So 150 for the X and let's say 400 for the Y. And then for the image that we're going to load in, we're going to do a string of Cody. Cody. Hey, there's Cody. I did create the sprite. But wait a second, they say that something's off there. After you pass this checkpoint, feel free to change the coordinates of the sprite. I did create a sprite. Is that not correct? I am confused. This.physics, I mean, it's working. We can see that it's working. So why is it having an issue? That was weird. Literally didn't change anything. All I did, I ran it and it was wrong, and then I ran it and it was right. Okay, just a bug, I guess. Implementing physics. In the previous exercise, we saw our sprite carried away by our game's gravity. The reason we were able to implement gravity was through the use of the physics plugin, which decides how game objects interact with each other. The plugin we're going to use is Phaser's Arcade Physics plugin. This plugin is great for adding gravity to our game and detecting collisions. To add the Arcade Physics plugin to our config object, thank you for the follow, we need to add a physics property and provide additional specifications to its value. Okay, so within our config object, we have physics. We have a physics object now, in addition to our scene object, or within it, I suppose. Okay, so the object has two keys, default and arcade. Default has a value of arcade, which tells Phaser to use the Arcade Physics plugin. And then arcade is another object within itself that contains details about how we want the physics to work for the specific game. So gravity, which is set to y of 300 to assign a downward gravity. The value 300 is based on personal preference. The higher the number, the stronger the effect of gravity is. I'm guessing that's like a ratio of pixels, right? So like you fall 300 pixels per second or something. And then like if you set, we'll play around with this, but if you set like the y to an x, then he'll like shoot across the screen instead of falling. Debug with a value of true to see the outline of objects in our game and their velocity. Oh, okay. So we'll call this physics.addSprite. We're actually telling Phaser's plugin to create our sprite for us and have the sprite follow the physics of the game. So in the config object, add a new property that has a key of physics and a value of an empty object. Okay, so we have our config object. We've got our Phaser set up with its scene. Now let's add the physics. Physics object. They said just keep it empty for now, but add a key of, or yeah, just an empty physics object. Within that, we'll populate it with default. Default with a key of with a value of arcade, comma after that, and then an arcade key with the value of an object. Okay. So then inside of the arcade's object, add the following key value pairs. Gravity set to 300 and debug to a value of true. Okay, so we'll want to set gravity to an object. This will be y 300. And then underneath that, add debug. Debug of true. We are debugging debugs. Now that we have physics in our game, we can uncomment the following line in create. Okay, so they added their sprite up here. Let's get rid of that comment and see what that does. Hey, there's Cody. He's fallen. Yeah, okay, so then we also have like an outline showing us the direction and magnitude of the velocity as he's falling. So, oh, let's reset that again. Whee! I wonder if you set it to like 600. Let's see, double the speed. What does that look like? Yeah, about twice as much. And then if we put him like above, put him like negative something, negative 300. Whee! Yeah, so just like actual gravity, right? It's acceleration, right? So the more time that he has to fall, the faster he falls squared. So at first he doesn't fall very fast, but then he starts going. Cool. Okay. And then, like, if you wanted to actually play the game, you would get rid of this debug line because you don't actually want to see the values, like the magnitudes. Yeah, so then you just see your character. But the debug is helpful, like, for, I could imagine, if you had, like, multiple characters, say, like, enemies, or say, like, you have your player character that's falling, and then you have, like a timed object that you wanted him to fall on. You could see the magnitudes and see if they match up or meet or something like that. It's just helpful to see, like, the directions and the velocities of different objects. Okay, so now we're going to add in static groups. Oh, Cody was there. He just fell out of the screen. Okay. So we're going to get that player sprite to land on some steady ground, but first we need to add a ground platform. This ground platform will not be affected by gravity, but we want it to interact with the player sprite. Therefore, we can't use this .addImage like we do for a background image, since images aren't affected by physics and don't interact with game objects. So what we need is this physics add static group to create a group object which keeps track of our platforms. Group objects need to... Oh, whoops. Oh, it looks like my session timed out, so it just sent an error to CodeCademy, but it is all right. Group objects are used to create and maintain sprites in a group. In this case, we can use this group object to create additional platforms. Ah, okay. So each time you initiate a platform, it'll access that group and push it there. And then they're adding in a platform in the example. All right, so this physics.add.static group we then create. So we'll add it here. This physics.add static group, and with a variable of platforms. So we do need some coordinates though. We'll just do like some central numbers for that, and then have it be, or I guess we want this to be at the bottom of the screen because this is where Cody's going to land. So just do it at like 10 pixels below Cody, and then have it to set it to platforms as the image. Platforms. Oh, I'm ahead of myself here. We're not doing that yet. Sorry about that. We are assigning this to a variable called platforms. I'm like thinking a step ahead. Let platforms equal this physics add static group. That's all we need for that line. That will create the group for us, and then we'll create it on the next line. Okay, so call the platforms platforms. There we are. Platforms.create. And then we'll add in what we had set for the static group. Does that work? Platforms.create. Under the defining the platforms variable, call this. Oh, they want it to be at a specific height. So we need to have it be 225 and then 510. Okay. But something is still off. So platforms.create. Oh, platform. That's it. There we go. Now we have our platform appear underneath Cody. However, he still falls through it because there are no collisions set up with Cody and the platform. We will do that in the next step. So let us move on to that. Detecting collisions. We have a platform sprite. We have a player sprite, but they're not interacting with each other. What's missing? Remember, our physics plugin determines how game objects interact. The way to decide these interactions is to create a collider object that checks if two game objects bump into each other. To set a collider object, we need to call this.physics.add.collider, and the collider method takes 3 arguments. The last one is optional. The first 2 are the game objects or group objects that collide. Here's an example of a collider with 2 arguments. So within their create function, they had a sprite, and they had 2 sprites. And then they added a this.physics.add.collider, and then they put in their 2 sprites as the arguments to the collider method. Okay, so let's do this with our Cody. Let's keep Cody from going off the screen. in create, call this. Okay. So call GameState.player.set collide world bounds to true. So far they just brought in what we had in the last exercise with Cody and the platform, and we will add in our game state here. So GameState.player.set collide world bounds, and set that to true. Okay, so we can't see Cody, but what's happening is that I don't know why they did this in this step and not like the previous one, but if we get rid of our platforms object for a second, we can see what this is actually doing. So now Cody, he'll fall, but then he'll stop at the edge of the frame. So the set collide world bounds, when you set that to true, it's saying that none of the sprites, or this sprite in particular, that sprite cannot exit the frame that you have set up. That's really helpful with the browser games like this, so you don't go flying off the screen. We saw this with like way back in the Business Bob game a few weeks back. I don't know that we used this method, but we had to set it to where if manually, like with 4 lines of code, if he reaches the end of the Y, if he reaches the end of the X in both directions, then don't let him move further. But this is just very simple. There's one line, set collide world bounds to true. Okay, so we'll go ahead and put our platform back and then do what they're asking in the second step here. So we're going to call a collider with the following arguments: the GameState.player and the platforms. So let's go ahead and do that. So it's going to be this.physics.add.collider. This is going to have the arguments of GameState.player and platforms. Okay, let's see how that works. Hey, we got a collision. Look at that. We got a collision. Cody is he's standing on a platform. Look at that. He's not falling through the screen, and also he's not falling through the platform. Sweet. All right. So adding controls and velocity. Until we can telepathically instruct characters in the games, we need physical controls to direct our player characters on how to move. One way we can implement controls is by using Phaser's this input keyboard create cursor keys method to create a useful object for keyboard inputs. Yes, we've seen this before. Seen this several times before. So the created object has the properties of up, down, left, right, space, and shift that are directly related to the keyboard keys. We can also access the .isDown property to the key to see if it is being pressed. If the key is pressed, we can change the horizontal velocity of a game object by using the setVelocityX method. So in their example, they have the cursor set with that create cursors keys method. Then in their update function, they check to see if each of the keys is down. And then if it is down, they set the velocity to a certain rate. And I think, again, like the velocity here is set to pixels per second. So in this case, X, he'll go like if the right... Basically what this is saying, if the right arrow key is down, then his X velocity will be at positive 160, or he'll go to the right at 160 pixels a second. I think that's the correct interpretation. And we can test that out, see if that looks right in a second here. Okay, so in the create function, create the cursor keys and assign it to GameState.cursors. All right, so we got to create the cursor keys first. So GameState.cursors. This will be set equal to this, and this is the long one. So this.input .keyboard .create cursor keys. Is that correct? I feel like it's longer than that. Create cursor keys. No, that is correct. We just need the method at the end of that. So keyboard input and cursor keys there. So we'll be using that GameState.cursors. Did I spell something wrong? Create cursor keys. Create cursor keys. This .input.keyboard GameState.cursors. Everything looks correct. Input create cursor keys. A cursor's property to the GameState object. GameState is spelled correctly. Dot cursors. This input keyboard create cursor keys. Yes. I think I did that. I don't know. We'll be using the GameState.cursors property. I don't know. I do not see my error. Okay, I'm literally gonna copy this then and see what the difference is. Let's see it on the next line here. It's identical. So what? What? Is this not, what am I not seeing? What? It's literally identical. Okay. If we can eliminate that way, like, that should still work, yeah? I don't know. I wrote down the code, but then input their code, which is the exact same code, and then it worked. Who knows? That was weird. Okay. We'll look at the create function and take note of GameState.player. It is our player sprite. So that is up here at the very top of create. They're adding in a physics physics object to GameState.player. They're also setting the scale to be half the size that he normally is, which is good because then it'll be easier for him to dodge all the bugs that will be falling. Okay, so in the update function, which is under here, add an if statement to check if the left arrow key is being pressed. Use cursors.left is down, which returns true if the left arrow key is down and false if it's not. Okay, let's go ahead and try that. So if the condition is true, then call the set velocity of negative 160. That's how we move the sprite to the left. So if this dot cursors left is down, right? So cursors left dot is down. So this is saying the left arrow key is pressed. Oh, not like that. Let's put the code block where it belongs there. So if this is true, then it returns true. Oh, okay, so they're just saying that. They're like, yeah, it's either truthy or falsy. If it is true, then call GameState.player set velocity to be set velocity of x to be negative 160. Okay. What did I do? I did add an if statement. GameState.cursors.left is down. Yep, we did that. It's got to be this line. Like, I don't understand. It's got to be this line, right? That line of code that we wrote that is exactly right, but is somehow wrong. Double check your spelling syntax. Set velocity GameState.player. Set velocity x is negative 160. Do we not need a semicolon there? This cursor's dot left is down. Oh, we can't use this here. We have to do GameState. GameState, because it's within the update function. There we go. That was my issue. I was not using the proper scope, because this, in this case, can't see. It's I don't think it can see. Like, GameState isn't set to this yet. You basically have to declare it first, and then you could use, I think you could use this like here. But anyway, yeah, we have to literally state game state. Okay, so then add an else if statement that checks cursor's right is down. If that condition is true, then call the opposite of what we had, of positive 160. So else if this is going to be game state cursor's right is down. If that key is being pressed, then we're going to do game state dot player dot set velocity x to be 160. Okay, cool. Lastly, we need to add an else condition, and if neither key is being pressed, call velocity of 0. Wait, really? So, can we move him? Can we move Cody? Whoa. Oh, I see. Okay. Yeah, so it's setting the velocity, but then when you press a key and you stop holding it down, then he keeps going. So basically the code is running and it's saying if it is down, then set the velocity to this, instead of like what we did with Business Bob was we said add it to his X value every frame, which is a little bit different. This one is just like set it to a static 160 versus while it's being held down, add this to the X value. You could do it either way. If you do it this way and you set it to a static value, then you have to add in an else statement here that then sets it back to 0. So I guess, yeah, the else statement wouldn't have a condition like that. This is just, if nothing is being pressed, then set the X velocity to 0. Player set velocity. So if any other key is being pressed or no keys at all, set it back to 0. And now we can move Cody. And when he move him and we stop moving him, he stops. Stop pressing the key, he stops. So right arrow, left arrow, right arrow, left arrow. If we increase this, say he zooms, he says zoomy off to 300, then he goes super fast to the right and it takes him a little longer to go to the left. This would be kind of cool for situations where you have like a conveyor belt. You could create like an if condition if you collide with the, or not if you're not colliding. It's not if you collide, but if you are standing on it. So like the two are in a state of collision, then to the right would be faster if the conveyor belt is going to the right, and then it's harder to go to the left because you're fighting against that belt motion. Yeah, and then also you can see on the edges of the screen here that I cannot move him out of the world bounds, which is fantastic. So he cannot go off screen. He is trapped in his little digital world. All right, adding enemies. At this point, we have a controllable player sprite, a platform, and a collider setup. Let's make some enemies. Unlike the player sprite, we probably want multiple enemies to triumph over. And unlike the platform, we should have physics affect them. Once again, Phaser has a handy method for us. This .physics.addGroup, which returns a group object that we can use to organize multiple enemy sprites. For instance, they add their own down here, physics add group, and then they create it. This is sort of the same as doing the static group. Let's see here. But I don't think the static group is affected by the physics. Yeah. So a static group is not affected by gravity, but it is affected by colliders. So like with our platform, we set that to a static group. So it's not, when it appears, it doesn't fall, but it can still collide with other things. So the physics engine is still enabled on it. It just doesn't, it's not affected by gravity. Variables, enemies, then we call enemies.create. So with the current code that they have in the first example, the enemies will always appear at the same coordinates. So that's not much of a challenge. Instead, we can randomize where this enemy's x coordinate is using the math random, and then multiply the value by the width of the screen. Okay, so then down here they have the updated code where they store a random x coordinate, so anywhere between 0 and 450, and then having that plugged into the generate enemy function. And since we want to create multiple enemies, we store that within a function. It becomes a factory function for us to create the multiple objects for the enemies. So every time that function runs, then we have a random x coordinate and then create an enemy. If we didn't have that, then if we didn't have that function to contain that, what would happen is that the x coordinate number would be set to a random number, but then it would only be set once. So it would be the same effect as if you just set the number manually. It would only run once, and then the enemies would always spawn from the same point. So that's why we have to contain that within a function, so that every time that function runs, then it would show, or it would create a new number. Okay, so let's do this. Let's first create an enemy using this physics add group and assign it to a variable of bugs. All right, so let bugs, or I guess this can be a constant because this is just pulling from images. So constant bugs equals this dot physics dot add dot group. Okay. Inside create, define an empty bug gen function that will house the logic for creating enemies. Okay. Is this, let's see. Okay, so that was within create as well. So we need an empty bug gen function. So bug gen, so declare it function and bug gen of, yeah, just have it be empty for the moment. Inside the body, create a variable xcord and assign it to math random. So let xcord, this is going to be equal to math.random times 450, which is just the width of the screen. And after defining xcord, call bugs.create. Bugs.create, this will create a bug object for us at the random x coordinate. And then it'll be at 10 of y, so they'll appear at the top of the screen with the image key of bug1. Now, of course, we could randomize this as well. For right now, we'll keep it like this, but at the end of this exercise, we'll go ahead and randomize like which bug appears. They might even have us do that. So, okay, so test out bug gen. Inside create, call bug gen to see a bug appear on screen. Okay, so bug gen, we'll call that function and see what happens. Oh, bug gen. Oh, I did it within the function itself. Let's do that outside of the function. Bug gen. There he is. Yeah, cool. So if we run that multiple times, now it will appear in random locations. So let's run that again. Yeah, so he's on the side of the screen. Run that again. It's a little bit further over. It's in the center of the screen. And right now we don't have a collision set up between the bug and Cody, so it just like falls right through him, falls out of the world. But yeah, we are creating an enemy in a random location at the top of the screen. Cool. All right, timed events. Currently our game creates a few enemy sprites and stops, or in our case, just one. So we could create a loop to consistently create more enemies to make the game more challenging. To implement this, we can call this time add event and pass in an object with specifications for how we want this loop to run. For instance, okay, so their example here, they have their generate enemy function. Then they do a constant variable equal to this add event. Okay, so in the example, they accessed the scene's time property, which is a built-in property. We don't have to create that ourselves. Called add event with an object representing the event that we want called. That object has 4 keys that provide different specifications. Callback has a value of generate enemy, which means this event will call the generate enemy function. So right here, the generate enemy, or whatever this is within the callback property, the value of the callback property, is referring to a function that has been created previously. Delay has a value of 100, which determines in milliseconds how long the delay is before executing the callback again. So this right here says that wait 100 milliseconds before you loop the callback function. Callback scope has a value of this, which sets the scene to this event it is used in. So basically this is just saying we want to use it in the scene that we can see on screen. Whereas like you could say if you wanted this to happen elsewhere, I don't know, like you would be changing in a browser-based game. I don't know when you would do this, but I guess it would be like if say an item that you had changes, like it affects another stage, another page, another level on screen, that when you get the item, then you could run like a loop function and put a delay on it, even though it wouldn't be displaying. I don't know why you would want this to be anything other than the current scene, but that's what the callback scope is doing. Okay, so then loop has a value of true, which means that this event will continue to execute until we remove it. Cool. All right, so in create, in a line under buggen, call this.time.add event and assign it to a variable buggen loop. Okay, so constant buggen loop. This is going to be equal to this.time.add event. Okay, so within this, we are going to create an object. We know that much. Oh, okay. So I guess we'll just keep it empty for now for that first step. Yeah. All right, so pass into add event an object with the following properties. So we'll create an object. Go ahead and give it a delay. Or we'll do our... Yeah, we'll do the delay first. Delay of 150, comma, callback of buggen, which was the function that we created earlier. Callback scope. This is going to be this scene, and the loop, which is going to be true. Okay. Good. Oh, look at that. Yeah, now we have bugs. We have bugs appearing on the screen. Sweet. And they're at a delay of 150. They're generating at random locations above the Cody. They're being affected by gravity. Sweet. Cool. Okay. So now, let's see. Removing enemies. Our enemy sprites threaten to take over the game if we don't remove them. We're going to need to use Phaser's destroy method to remove our enemy sprites from our game. So let's first take a second to consider when we want our enemies removed. For our game, bugs should disappear when they hit the ground. Therefore, we need a collider for enemies and platforms. Unlike the one we previously created, this collider takes a third argument of a callback function. Okay. So they add a collider here, the enemies and platforms, and then they destroy the single enemy that hits it. Okay, let's create that. So inside of create, after our buggen loop, that's so cool. We've seen this before. We saw this in like I think the first time was in our Mole on Earther game, where there was a loop like this, and we were trying to figure out what delay meant, what callback meant, and all this. But now we know. Now we know what each of those key value pairs means. And yeah, and then if we change this to like 200, or say like 500, say 500, ignore this for a second, 500, yeah, they're falling a bit slower if we change that delay, because that's the number of milliseconds between spawning. Cool. Anyway, okay, back to this. All right, so we're adding a collider between them and the platform. So this dot physics dot add dot collider with the arguments of bugs and platforms. They emphasize that it has to be in that order, but I'm not sure why. And then we have to, okay, and that's all that we need for right now. Then add a third argument inside. Yeah, see, look, okay, now we have a collider with the bug objects that we're spawning, but we're not destroying them. So now they will completely obscure Cody, and he'll be lost in a sea of bugs. Poor Cody. All right, add a third argument inside collider. Pass an anonymous function that has one parameter of bug. Okay, so for our third argument within this collider, put in a function. Our argument for that, our parameter, is going to be bug. And within this function, we will call bug.destroy. I'll go ahead and mention this because I tend to get confused about these things, but bug, right, is essentially an alias for what this function is seeing. So it's saying whatever bug is to destroy it, right? And we'll go ahead and start this. So what it does is that, yeah, it makes the bugs disappear. Now they won't cover Cody as he's moving around. Yeah. And they'll just pop out of existence once they hit the bottom of the screen. Of course, they're not hurting Cody yet. We'll code that in a second. But okay, so with the bug parameter set, now at this point, I'm just going to be spitballing a little bit here because I sort of understand it, but I want to understand it specifically. So it's saying that whatever bug is, it's going to destroy that. Bug is just an alias for something. I'm guessing it's like this function refers to the parameter set here, and since this is the first, since bugs is the first parameter of the collider, then the collider function will take that and then destroy it. And this parameter could be labeled anything. You could label it strawberries if you wanted. And then just as long as this is the same, it'll do, like, it doesn't matter whether it's called bugs or not. Oh, I need to label that. There we go. Spell that correctly. Yeah. So that's just an alias. As long as it's named the same, it doesn't really matter what you name it. We're just telling ourselves that bug, that it's only destroying a single bug. Now, if we flip this, the reason why this order matters is because if we flip this to be platforms and then bugs, it would destroy the platform when they collide. That's a theory. And it's not correct, but... Oh, because it's not correct because this is not a real thing. Try that again. There we go, yeah. Hey, and Cody actually fell too, because the collider was no longer there, so he fell to the bottom of the screen. That was cool. That's cool. So that you could like program in ice blocks like that, right? So the ice block disappears because, you know, you stepped on it and it broke, and then you fall to the next collider. Okay, cool. Now, also, just having random thoughts here. Like with Mario games, so if you go to the edge of the screen, there is like, well, if you go to the left edge, right? Okay, I'm thinking of like, yeah, I guess they don't have that. So I don't know how you scroll screens, but what I could theorize is that at the bottom of the screen they don't have a collider for the world bounds, so then Mario just falls through, and then he falls into a pit and you have to restart. but they have the colliders for the world bounds elsewhere. Or when he reaches the world bounds, then the screen moves. But we're not quite there yet. We're not to a side scroller point yet. We're still in the arcade mode. But okay, so that's the difference if you add in platforms before bugs for this. You could have it be where the function doesn't, like it has a second argument of platform, or sorry, the first argument here would be platform. And again, it doesn't matter what you label these, but this is just telling us what it's doing to our English minds. And so now in this case, since we have bug as the second parameter, it's going to access the second parameter of the collider method and then destroy it. So now it should be the same as we had before. We're just changing up. Yeah, we're changing up the code a little bit to show why the order matters there. But it can be accomplished either way. So let's go back to what we had. Just undo all that and back to the bug. Bug.destroy. There you go. That way our code is a little bit neater, a little bit tidier. Okay. Moving on. Adding a score. So one thing we're still missing from our game is a scoring system to motivate our players. We can store our score property as our score or store property in the game state object and increase it as the game progresses. To display the score, we can call this add text. We should also consider that we want to increase the score, or when we want to increase the score. For example, increase the score every 10 seconds, or each time an enemy is generated, or how much the player sprite moves, etc. For our game, we could increase the score each time the player sprite dodges a bug. When a player dodges a bug, it collides with the platform. So we can add our logic in that collider object. Okay. So when a game starts, we should set a new property with a key of score and a value of 0 in the game state object. Okay, so they're going to walk us through with examples, but this is pretty straightforward, so I'm just going to jump into it. We just need to remember that the score text is what we need to access, or the set text method is what we need to change it. But they'll walk us through that in a second here. So first, let's add a score key inside of our game state object with the value of 0. All right, and then that populates underneath because they have a score text set right here. So they already gave us the position, what we're actually seeing on screen. This is just the text that will appear, and then the font size, basically the styling of that text. If we change this value here to like 105, it'll move to the left, be set over there. And then if we set it back, it'll go back to the center, like so. Okay, so then inside of the callback of bugs and platforms collider object, increase the score by 10 every time a bug collides with the ground. So within the collider here, we're going to add another line. Game state dot score plus equals 10. And this will make it so that every time a bug hits the ground, the score doesn't change. Because we haven't set the text yet. But let's go ahead and satisfy the, if we can. I might have to reload here. Let's go ahead and reload. And make sure that our code is still the same. Yeah, it's still the same. Okay, so now, once it thinks about it and sees that we are doing this properly, we're incrementing our score, but we're not displaying the new score. So basically, the variable is changing within the game state, and if we access that, it would show us like the new score value. But for now, it's just set to a certain value that we can't see. We have to actually display it. I'll go ahead and start writing that while there it is. There it is, caught up. So now we want to display it. So the syntax for this is game state, and then you access the property that you want to change. Game state score text. This has a text property that we can directly access with set text. Rather than like creating a new text object where it would overlay over the previous one. We want to just change it. The way we do that is by doing the set text. So we want to have this string be in backticks because we're going to do a template literal, fancy for adding a variable within a string of text. So just set it to the same as before. Score, $, braces, game state dot score. Any of you been watching so far, this isn't new to you. Just for anyone who hasn't seen this before, this is the syntax for adding a variable in to a string of text. All right, so now what's happening here is it's taking the GameState.score value, which is being updated every time a bug hits the platform, and then adding it to the score at the bottom and displaying that text. So yeah, now we have it's raining bugs, and our score is increasing to infinity because Cody is invincible at the moment. But isn't that cool? So all that we did, we thought to ourselves, okay, so we got these bugs colliding with a platform, and every time a bug hits the platform, or aka every time Cody avoids a bug, it will hit the platform. So therefore, every time it hits the platform, let's increase the score. And oh, by the way, we already have something that's accessing that moment when it happens. So we can add that code in there. Easy as pie. All right, the losing condition. So it's great to see our score increase, but it doesn't mean much if there's no way to lose. One common losing condition is when a player sprite collides with an enemy sprite. This means we need to include another collider object with a callback in create. So this.physics.add collider, player enemies, logic to the end of the game. Okay, so for our game, it ends when the player, sprite, and a bug collide. When this event happens, we also want certain things to stop. For instance, we don't want our game to continue creating bugs. We should call destroy on the loop that creates our bugs. Another thing we would want to stop is the physics of our game. To put a pause on the physics, we call this physics.pause. In the code example above, notice the use of an arrow function for a callback instead of an anonymous function. Okay, so they have an arrow function up here in the example. The reason for this is that an arrow function implicitly binds the this keyword. We know that we want to call this.physics.pause, and we need this to reference the scene object. Therefore, we use an arrow function to bind this as the scene object. To read more about that, you can look at the documentation, but basically it's just making sure that the physics object is within the scene, or making sure that we're referencing the scene when we're saying this. Let's see how it works in our code. So let's create a collider at the bottom of our create here. Look at all this. Look at all this. All this. We've added so much so far. So many different kinds of things. We've added sprites, interactions, keyboard events, time events. It's pretty cool. Pretty cool. This.physics.add.collider. The method has the following arguments in the following order. All right, GameState.player. Like we saw earlier, the order only matters depending on your function. We'll go ahead and do it the way they said it though. Bugs, comma. This is going to be an empty arrow function, empty parentheses. Use that fat arrow. And braces. All right. So inside of that, you need to call destroy on the bug gen loop to stop the timer event that creates the falling bugs. That's very concise and I like it. Okay, so bug gen, all you do is call destroy on your loop that you created for the bugs. Destroy. Voila. And then, oh, that's interesting. Oh, I see. So if it collides with the player, then it stops the loop. Still, it still doesn't end the game because we haven't added that, but it stops the loop. Cool. Inside the same callback function, under buggen destroy, call this physics.pause. All right, this.physics game.pause. And now let's see when a bug collides with Cody, it stops, it pauses the game. It doesn't create any more bugs, and it just pauses all of the physics. Lastly, still inside the callback, add the text for the players to know that the game is over. So just create a game over text. All right, so with this, it would be just this add text, yeah. I'm going to go ahead and set it to a variable, though. I'm going to say, like, constant. Although I guess you wouldn't need it to appear if the game isn't over. Yeah. But perhaps, like, if you win the game, then you'd want to access the variable. But the variable would need to have global scope, not function scope. So let's not create a variable for that. Let's just do this dot add dot text. This takes 4 properties. Try to hit it at the middle of the screen, so the lower middle. So 150, or maybe this needs to be. Yeah, I'll go with 150 for now. 150, 200, and the text we're going to put in is game over. Fourth parameter here is going to be a fill of black text. So remember, if it's text, you need to add in the string with a hashtag and then the hex code. So 3 or 6 zeros there, and I think that should be enough. It was not enough. Oh, right, because we didn't add the font size. We need to add the font too. So within this, the style is the last property. So we need to add in an object with style. What this looks like is the font size. I think this is just like literally just called font size, yeah. So up here they have an example where they're setting the score text. This is the last property of that. So font size with a fill. So down here in our text, let's add that in. So we need to do font size of 15 pixels, px, comma, and then fill of, let me get myself straight here, fill of black. Let's see if that works. Still not. Game is not defined. Oh, okay. So, wait a second. So we need to add in, yeah. So we do need to make this a variable. So constant. Nope, we don't need to do that. All we need to do is assign it a property. So game state dot just end text. You can name this whatever you want. Just have it be a new property in the game state object. This way, it actually knows where to add it, because right now it doesn't. It's not. It's not adding it to anywhere. Of course, they just say that the game is not defined. Well, what did I do? What did I do? Font size fill. I bet it was within this. What did I do? Oh, yeah. I'm missing a... This is funny. Okay. Right there. I added like an extra parentheses and then didn't have the brace in the right place. And it's still wrong because of something else. This add text, this is that. Oh, this does need, we do need an extra, I was just missing a brace underneath there. And now that's connected to, not this, but here. So that's one set of parentheses. This is a set of braces. Oh, and then we need the last brace for the create function. Is that gonna work? I think so. I think I fixed all my syntax errors. Nope, still not. All right, where does this connect? Where does this connect? Okay, so that connects all the way back up to create. This connects to the collider. This connects to that. This connects to that. This connects to that. Game states .end text. I'm gonna check to see font size. This object is the same, right? Font size. Oh, I see. I see. The pixels need to be within quotes as well. There we go. Yeah. See, I knew we had the words right. I just wondered if the syntax was off a bit, which it was. That appeared in a nice place there. Game over. Well, let's go ahead and move that over to the right a bit. So let's make it 200. Let's go ahead and whenever we lose, there we go. Game over. Let's move that back to like 180. 180. And let a bug hit him. There we go. Okay. Seems to be center-ish, so we'll keep it that way. Now, let's learn how to reset the scene. So once the game ends, we should allow the players to restart and try again. Phaser has a convenient method to solve this issue. This.scene.restart. Like the method's name implies, this.scene.restart restarts the scene. Nice. We should also consider when we want to restart the scene. Each game has different criteria. For our game, we want this option to be available after the player's sprite has collided with a bug. We should also give our players an option to restart when they choose to. One way to implement this logic is to add onto the callback function of the player and bugs collider object. We'll add an event listener for a mouse click or pointer up event. When this occurs, then we'll restart the scene. Let's add this feature in. So in the callback function of GameState.player, and bugs collider, add an event listener by calling this.input.on with the arguments in the following order. So let's scroll back down to our collider. They've added a click to restart text at the bottom as well. Hey, look at that. They added, that was cool. Look at that. They added it in the right place, or the right place. They exactly the same place that we added it before, 180 and 250. Cool. All right, so we're going to add a listener in within the collider of GameState.player and bugs. This will check on... Oh, okay, yeah, just this, right? This.input.on. So within the scene, what the input it has, it'll check to see about the pointer up. Pointer up, and then an empty arrow callback. Again, the arrow callbacks implicitly bind the scene to this, this keyword. Okay. Inside the function body of the anonymous callback, let's reassign game state score to 0 to restart the game. Game state.score equals 0. Under the reassignment of the score, call this scene.restart. This scene.restart. After you pass this checkpoint and play Bug Dodger, you'll be able to restart the game after it's over by clicking. There we go. So we play it, get some points, and then get hit by a bug. Game over, click to restart, pauses the physics, and then when we click on it, it restarts the game, and we're able to play it again. And if you wanted to change this to be, let's say, like space instead, or something else, yeah, let's try, I think we set the cursor keys on this one. Let's try space, see if that works. No, it does not work. I'm not sure. I think there's another way to add in Yeah. So with the cursor keys, you have to add it in like this. So if GameState.cursors is down, we'll go ahead and keep it this way. We'll, in the next stage, we'll code in how to do it with space instead of clicking. I just feel like if someone's playing the game with the arrow keys and then they get hit by a bug, it's kind of tedious to go back to your mouse and then click it again. So instead, I'd rather have it be like, if you get hit by a bug, then you can press space and then start it again. Yeah, arrow functions give you headaches. Yeah, they've given me a few headaches as well. All right, great job. If you're following along, great job to you. Great job using Phaser's Arcade Physics plugin to make an entire game. In this exercise, we covered creating sprites that are affected by physics, creating groups of sprites affected by physics, and creating groups of sprites not affected by physics. We saw that with the difference of static group versus just group. Adding colliders between sprites and groups of sprites, creating a loop to continuously execute a function. I'm probably the most excited about that because I was really wondering how to loop things with time. I remember, I forget, I guess it must have been the Mole Unearther game where we were like, how do we do this every second? How do we increment the score or whatever we were trying to do? Or maybe it was probably the cube matching game. I had the most trouble with that one. All right, we learned how to pause physics and restart a scene. If you want to challenge yourself, change the delay to make the game more difficult. Compare the differences between overlap and collider. And check for spacebar to make the player sprite do something. Implement a high score system. Okay, so in this review, the review page, I already worked on this a little bit, so I kind of did the extra credit on my own earlier, but I'll walk through how to do that. So with a high score, it's probably the easiest, or I guess the changing the delay is the easiest. So the way you would do that is within the bug gen loop, you would set the delay to any number you please. The smaller the number, the harder it's going to be because the more bugs populate. So right now it's set to 800. And actually this game is a little more robust too, because what I did with this one, I added in like an increment where as the score increases, the difficulty increases. So once you get to a certain score, then the level will change and the bugs will start appearing faster. But they also are appearing faster per every like 10 points, like a millisecond every 10 points. But not to muddy the waters. So the way that you would change the delay, let's get hit by a bug here. There we go. The way you would change the delay is here. So if you set it to like 100, it would appear super fast. So it'd be super difficult to start out with. And you could always make that easier. Put it to a full second, you use 1,000, etc. So that's the delay. The high score system, we'll go over that next. So the high score, basically you just need to set another property within the GameState object and then display it just like we did with score. So underneath the GameState.score text, I added a GameState.highscore text with the same properties as score, except it's moved over to the left side of the screen. And then the logic for that, if we go to like high score,